statistics. These notes will cover all of lesson 5.2. We're going to work with normal distributions to find probabilities. Now, the only difference between lesson 5.1 and lesson 5.2 is that what you're going to be given to start with hasn't been normalized. In other words, the mean is not 0 and the standard deviation is not 1 for the data that you're going to be given. We're going to have to use those z-scores to help us get there. So what we're going to have to do is look at the situation given. For this one, the mean is 500. The standard deviation is shown to be 100. What we need to do is normalize this. We want to use a z-score, and by switching this over to a z-score, that means your mean is going to become 0 and your standard deviation is going to become 1. So in order to get your mean to become 0 and your standard deviation to become 1, we're going to take this data right here and we're going to switch it over to a z-score. So that's what we're showing you here in the next slide. So if I was interested in the probability of an event happening where that event is less than, say, 600. So let's say, what's the probability of there being less than 600 people at the zoo on any given day? You would have to know the mean and standard deviation for that particular day, and then you could take that over here to this formula right here, and you could change it to a z-score. That gives you a z-score of 1. And so your probability statement from here is now switched to that for that z-score. You're still finding the area on the left side, but now you're able to use that table that's in the back of the book to help you find the probability. So I'm going to walk you through how to do that with several different examples. So for the first one, we have people using their computers on average of 2.4 years before they upgrade. The standard deviation is 0.5. A computer owner is selected at random. Find the probability that he or she will use it for fewer than 2 years before upgrading. So we're going to write out what we're given first. What we want to find is the probability that the owner uses it for less than 2 years before they upgrade. So here in just a minute, we're going to switch that over to a probability in terms of a z-score. We're going to put the z-score that we find right here. In order to find a z-score, you're going to take your x value, which is 2, minus your mean, and then divide by your standard deviation. That z-score for this problem is negative 0.80. So here's our mean. Here was 2.4. Our standard deviation was 0.5. And so we were looking at maybe this area before. Now what we're going to be doing, our mean here is now, or we're at 0. We're at negative 0.8. And now we're finding this area right here. Those areas are going to be the same. This negative 0.8 goes right here. And then I'm going to go to that table in my book. I believe it was page A37. And I'm going to look up the area. So the probability of somebody keeping their computer less than 2 years before they upgrade is 0.2119. In other words, that's about a 21% chance that that's going to happen. And before we move on, I'm just verifying that I gave you the right page number for that table, and I did not. So let me fix that real quick. It's page A16. I said A37. Sorry about that. Okay, so probability table. It's the standard normal distribution, pages A16 to A17. So it's the same table that you use for lesson 5.1. Okay, so I would have looked up negative 0.8 and then ran all the way to the right where it's 0.00, and then you'll see the 0.2119. This right here is your final answer for this problem. Okay, for the next one. You go to the supermarket. Shopper spends an average of 45 minutes there with a standard deviation of 12 minutes in the store. The length of the time is normally distributed, so we have the bell curve. Shopper enters the store. What's the probability that the shopper is going to be there between 24 and 54 minutes? So the mean is 45. Standard deviation is 12. All right, so we're looking for the probability that the person's there between 24 and 54 minutes. So what is that in terms of a z-score? It's something is less than z is less than something else. So we're going to find the z-scores. The notation I'm going to use looks like this. I'm going to do the z-score first for 24. And so I'm going to take 24 minus the mean divided by 12, which is the standard deviation, negative 1.75. I'm going to put that right here. The next z-score is for 54. And that comes out to be 0.75. And that one's going to go right here. Now, for this one, I'm just going to show you the graph in terms of z. So here's your mean of 0. Let's put 0.75 right here. We'll put negative 1.75 right here. And we're finding this area in between. That will be our probability. In lesson 5.1, you subtracted the larger area from the smaller area. So you would have looked up this one first. Oops, I meant to use a highlighter there. You looked up this one first in your table. And so this probability would be 0.7734. And then I would look up the probability for negative 1.75 and then subtract. Okay, so no different than the work here you would have done in lesson 5.1. For the next problem, same mean and standard deviation. We're looking at more than 39 minutes are spent in the store. So we're looking for the probability that x is greater than 39. That means you're going to have to find a new z-score. So 39 minus 45 divided by 12 is negative 0.50. If I look at that on my curve, it looks like this. Here's 0. We'll put negative 1/2 here, and you're finding this area on the right. We know that the area on the right is 1 minus the area that we're going to find in our table. And then the extension of this would be, what if 200 shoppers came to the store? How many would you expect to be in there more than 39 minutes? So if I know the percentage of that happening is 0.6915, I will just multiply that by my 200 shoppers, and then I will get about 138. So out of 200 shoppers, I would expect 138 to be in there more than 39 minutes. And finally, how do I do this with a graphing, with my graphing calculator? So we're just going to end, and I'll show you how to do that real quick, and then these notes are finished. So assume that your cholesterol level, if you're male, they're normally distributed. You have a mean of 215 milligrams per deciliter and a standard deviation of 25 milligrams. We select a randomly selected male from the US. What's the probability that his cholesterol is less than 175? Okay, so what you need to record here is your mean, your standard deviation, and we're finding X is less than 175. So what you're going to do is you're going to turn on your calculator, of course, go to your regular calculating screen, hit menu, and then we went 5 for probability, and then we went 5 for distributions, and then we went normal CDF, which is option 2. It says lower bound. Your lower bound will be 0 because you're going from 175 down, so between 0 and 175. Your upper bound is 175. Your mean is 215. Your standard deviation is 25. And if you put that into your calculator, you're going to get roughly 0.0548. And I'm going to try that one more time. I deleted something on my calculator and my answer went away, so I just wanted to check that. Yep, there you go. So that's how you would take care of that in your calculator. If I were doing a problem such as this problem here where I was doing the probability of X is greater than 39, so on the previous example, if I had to enter that into my calculator, my lower bound would be 39, and my upper bound, that would be tricky because it would be infinity. So I don't think you can enter that. I do believe you're going to have to do 1 minus the probability that X is less than 39. So keep that in mind. Your calculator has to have a set upper bound and lower bound. So if infinity is one of them, you're going to have to think outside the box and put it in there a different way. But if you're doing in between, like this one, 24 to 54, then I think it's pretty self-explanatory that your lower bound is 24 and your upper bound would be 54. Okay. That's it for your notes. I just left this slide on here to show you a few other programs and calculator directions, but that's it for the notes. Take care, you guys.